Okay, so let's start. Okay, I think it's supposed to the paper. I think paper 1 July 14 and paper 2 July 15, right? I go to paper 1 July 14 first. If you got any questions, then we go to paper 2. Okay, paper 1 July 14, right? Okay, let me open up. Okay, I think this is the paper. So anybody have any questions? You try. Any questions? You have a problem? No questions?
Sir.
Yeah.
17.
17. Okay, good. So we go to 17. Oh, okay. This is out of syllabus. Sorry, already removed from syllabus. The amorphous solid. Okay, we skip this. Any other question? This is not in your syllabus anymore.
Number 9.
Number 9. Okay, good. Okay, good question. Number 9. Okay, class. Everyone, please give a try. Those who haven't tried. Question 9. Okay, an apple is at rest on the ground. The diagram shows 3 forces of equal magnitude. Weight acting down. P is the push of apple on ground, and R is the normal contact force of ground on the apple. Okay. So which row in the table shows the Newton's first law and Newton's third law by being applied correctly? Okay, Newton's first law. Okay, this is tricky. Okay. Okay, let me see. Okay, you see here. Of course, the weight acting down. Weight is acting down. Weight is acting down. Okay, we know that weight is acting down, and you get a normal direction. We know that. But then, what is this new force? This force P. P is the push of apple on the ground. Okay, maybe most of you think that is it push of apple on the ground and the weight, is it same? Is it same or not necessarily always same?
Not necessarily.
Yeah.
Not necessarily.
Not necessarily. Not necessarily. Not always same. When it's not same. Anyone? When it's not same.
When the force is enough to like how do I say it? Like to break it like that.
To break it. When the, let's say the object stands there, you are standing there. Let's say you instead of object I put you. Let's say you are standing there. When you stand on the ground, maybe you are a weight of 800 Newton. Let's say that's your weight, and that's your weight. So you are standing there, weight. So if you are in rest, you are just standing on the ground. You are in rest. So the weight and the P, the force you are exerting on the ground, the P, will be the same. Will be the same. Condition is you have been rest. Okay, but if you jump, you just jump from a certain height, you come down, you jump and you land on the ground. You land on the ground. Then in this case, you are just jumping, impact. In this case, the P and the weight, it's not same. Okay, P greater or W greater when you land on the ground? Anyone? P greater, right?
Yeah.
P will be greater. P definitely going to be greater than W. So they are not same. P and W. not same. Okay, so now, so that is the force P. P. The P is the force you exert to the ground, and the weight, okay, P should be greater than W when you accelerate down, when your acceleration happens. Because of P, so the force exerting to the ground is P, so the ground going to push you back with R. Okay, with R, you push you back with R. So P and R is always same. Okay, this is Newton's third law. This is your Newton's third law. Newton's third law. Newton's third law. The P should be equals to R. P is what? P is force exerted by the object 1 and 2. P is force exerted by 1 to 2. Okay, action. Reaction is R. R is reaction force. Already stated reaction force. The force exerted by 2 to 1. So P and R is definitely an action-reaction pair. If it's an action-reaction pair, it must have some features, right? What are the features of action-reaction pair? It must be same magnitude. Okay, must be act on different body. Must act on different body. Okay, and yeah, P and R act on different body. Right? P acting on the body 2, R acting on the body 1. So P and R is an action-reaction pair, different body, and of course must be same magnitude. Same magnitude. Same magnitude is already there. Must be oppositely directed. Must be oppositely directed. And the fourth one must be, we call it same type. Must be same type. Okay. So Newton's third law, which is same? The R and P same. R and P same. R and P same. So answer could be A or D only. Okay, but now that's your Newton's third law. RP is the action-reaction pair, no doubt. Okay. Okay, now go for first law. Newton's first law says what? An object will be in rest or move with constant velocity, right? Constant velocity. If net force is 0, if the net force is 0. So, which applies Newton's first law? To apply the Newton's first law, let's say you take the first body, you must consider all forces acting on the first body only. Newton's first law only talking about force acting on that one body only, not the other body. Third law is talking about the force acting to the first body to the second body action, second body to the first body reaction. That's the third law. Third law involving two body, but first law only involving one body and is all is force. So in this case, we take the body one. Body one is the sphere only the sphere only. One. Okay, what are the force acting on the body? The force acting down is weight. The force acting up is the reaction force for the body one. This is the first body force. P is the force acting on the second body. You can't include P here. So because the body is in rest, applying first law, so R should be equal to W. R should be equal to W because the net force must be 0. The net force must be 0. So only R and W acting on the first body. So R equals W based on Newton's first law. So therefore the answer should be D. Can you understand?
Yes.
Okay, good. Yeah. Any other question?
$27.
27. Okay, we go to 27. Okay, this is a very good question too. Okay, those who haven't tried, give a try. What's the answer for this? This is about electric field. Just recently we done a topic. Positively charged sphere falls from rest. Remember, it falls from rest. Fall from rest vertically in a vacuum between two long parallel plates carrying opposite charges. Which one of the following diagram best shows the path followed by the sphere? or you have a two parallel plate, and negative and positive. A positive charge is just dropped. A positive charge is just dropped. We don't know where it dropped. It might drop here. Okay, positive charge, or according to the diagram, it might drop here. Okay, it's a positive charge, right? Positive charge. Okay, because it's a positive charge when it dropped, it should get close to the negative plate, right? It's a positive charge one. I think DC doesn't make sense, right? Positive must go to positive plate, for negative plate, right? So yeah. So the positive charge going to the positive plate. I cannot, because it won't launch from rest. So the answer should be A or B only. A positive charge placed here, it should go towards the negative plate, goes towards the negative plate. But now the thing is it going to be take a curve, or is it going to make a straight line? Okay, it's going to be make a straight line or make a curve. Okay, how to find this? Oh, this is tricky. Okay, you see, check the force on the positive charge. The charge is in rest. I follow the B. Charge is in rest. What are the force acting on the charge at this point? The electric force acting where? To the left, right? Electric force acting here, and to the right. This is the force due to electric. Any other force acting here? Any other force acting here? We can say the weight. The weight is acting down, and the weight is pulling it down. Okay, the weight is pulling it down because it start from rest. Therefore, which direction the net force will be? Electric force is here, magnetic force, weight is down. So the net force will be this direction. The net force will be here. Net force will be here. Okay. So because it is in rest, it immediately going to follow the direction of the net force already. You just follow the direction of the net force. So B is the answer. Okay, it follows the direction of the net force. Yes, A also could be the answer if the object is launched vertically down with a velocity. It was pushed, it was thrown down. It's thrown down with the velocity of V. Then you take the A path. Because what is this? The F is still acting to the left and the weight acting down. So still the net force is diagonal. Net force is diagonal here. Because it launched with vertically down, it takes time to go to the direction of the net force. It takes time to go to the direction of the force. So you take a curve, but eventually towards the end, it will go to the direction of the net force. So it makes a curve first and finally go to the direction of the net force. Once it reaches the direction of the net force, you make a straight line after that. Okay. Same thing. What? Earth is here. Okay. If your object, if it's in rest, if you just drop rest, it goes straight to the direction of the net force. The net force in this case is a weight. But let's say you throw an object horizontally like this. The V is here, but the net force is down, right? Is it immediately go down? No, right? It takes time, right? It takes time to go down, make a curve. Finally, it may go to the direction of the net force. You take a parabolic path. But originally, rest means if it's rest means it immediately go to the direction of net force. So it just goes straight line, 1D, one dimension. If the launching velocity and the net force is a different direction, the object will take a curve eventually and finally only go to the direction of the net force. It takes time. So in this case, because they say it's rest, therefore immediately going to follow the direction of the net force. The net force is diagonal here, so it go a straight line. It go 1D motion. It go one dimension motion. So I choose B. B is the correct answer. Can you understand?
Yes, thank you, teacher.
Yeah.
Good. And okay, any other question?
Sir.
Question? Yeah.
Is the force in the electric field always constant?
Yeah, the force, the electric force, the force due to electric field, the Fe Fe will be always constant, because why? It's a uniform field. It's a uniform field. Uniform field means what? The field is constant. So F equals to QE, right? QE, right? The F will be constant as long as the charge and the electric field constant. Because parallel pit produces a constant electric field, therefore the force due to electric field will be constant. Okay.
So it's not affected by acceleration, right?
No. Force, is it force affected by the acceleration or acceleration affected by force?
Oh, okay.
Okay, good.
Thank you, sir.
Okay. Any other question?
So 26.
Okay, we go to 26. Okay, the others, give a try. 26 is a wave. Wave. Okay. A musical organ produces notes by blowing air into the set of pipes that are open at one end and closed at the other. Yes, this is a stationary wave. When you see a question of stationary wave, check, is it a closed pipe? Is it an open pipe? Or is it a string? Okay. Or is it a microwave? This is the 4 options lah. Microwave. Normally these 3. Okay, this case looks like this. One edge is closed. Okay, when one edge is closed, recall back all the pattern. What are the pattern can form? The closed end is always form a node. The open end always forms a antinode. So lowest pattern going to be like this, right? Going to be like this. Going to be like this. Yeah. Okay. And following pattern, as I said, the pattern going to be compressed until another antinode is formed. This is the following one, and so on. Okay, what they want. So, what are the lowest frequency? What is the lowest frequency? That means they are looking for the fundamental frequency. F naught. Fundamental lowest frequency means the wavelength going to be the largest. Largest happened at this appearance, the first appearance. This is the longest wavelength. What is the lowest frequency sound wave? Okay, good. So they want the lowest frequency. F naught. So how do you find F naught? F naught is V over lambda naught, right? Lambda naught. So do you know speed of sound? Speed of sound given 330, so 320, so 320. Wavelength. Wavelength, you have to get it from the tube size, right? Tube size. Let's say the tube is, what is the tube size here? Tube size is 10 meter. It's 10 meter. So tube size is 10 meter means this how many wavelength? How many wavelength is this? This is the quarter wavelength, right? Go up, come down, and go up like this. So this is how many wavelength? Quarter wavelength. So conclusion is what? Quarter wavelength is how many meter? 10 meter, the size of the pipe. So the wavelength is 40 meter. It's 40 meter. So put the wavelength is 40 meter. So you get a frequency. What you get? 8. So you get 8 hertz. So answer should be B. Do you understand? The important is the pattern. The pattern.
Thank you, sir.
Yeah, can you check, is it a closed pipe, open pipe, or a string? For all of them have the different pattern one. Closed pipe, this is the pattern. If it's an open pipe, how's the pattern start with? It's going to be antinode here, center node. This also going to be antinode. So it's going to be like this, right? Sorry, it's going to be like this shape. This L equals to how many lambda? L equals to crest to crest, so it's half lambda. So from here you can find the wavelength. Yeah. Okay, any other question?
18.
18, okay, we go for 18. Okay. Yeah, evaporation was shifted to A2. Okay, you learn evaporation only in A2. Yeah, but yeah, so evaporation is in A2. We'll be learning that. But anyway, you learn in your O levels what? Evaporation and boiling. So requires heat energy. Yeah, evaporation requires heat energy, but the heat energy is taken from internally, from inside. Not external heat energy. It does not require external heat energy. Here the point is not clear. Requires heat energy or heat energy from the surrounding. No, it not required heat energy from the surrounding. But heat energy, it takes the energy from the particle. Okay, occurs only at a particular temperature. Evaporation occurs any temperature. One. So correct. Occurs only at a particular temperature. No, it occurs at any temperature. Can cause change in temperature of the remaining liquid. Yes, it change the temperature. What? The liquid become cooler after evaporation happens. So correct. This is definitely wrong. Correct, definitely wrong. Oh, this is the point. Requires heat energy. External heat energy not required. So therefore, I think I go for D. Requires heat energy. External heat energy not required. Okay, but it takes energy internally. What's the answer given for this?
D.
Should be D lah. Heat energy here they talk about is the external heat energy not required. Evaporation only happens in a very high temperature liquid. So high temperature liquid takes energy from the internal energy of the substance. No heat is required. No need to heat evaporation to happen. Boiling, yes, you need to apply heat lah. Okay, but anyway, this is move on to A2. We will do that in A2. Any other question?
28.
23.
28.
Okay, we go to 28. Oh, so 28. Okay, this one. Oh, this is one. Oh, electric field. Okay, 28. Okay, look at the question first before we check the answer. Okay. The diagram below shows an electric field line in a region of space. What is the following diagram best shows the variation with the distance g of the potential V along the line xy? Along the line xy, how the potential is changing. How the potential is changing. Okay, they're asking, so if you plot potential versus D starts from the X line. From X, we go to Y, the D. So, you know, this like the positive plate, this is like a negative plate line. It's like a negative plate. Okay, but it's not a parallel plate actually, because the line is curving. It's not a uniform field. But anyway, the X is the origin to a positive charge. So because the arrow is pointing to the right, potential of X must be very high. Potential must be very high for the X. Vx must be higher. Vy definitely must be lower. Vy must be lower. Vy must be lower. Not zero, lower. So it should be high to low. Why Vx is higher? Because the arrow is to the right. The field is to the right. So X at high potential. Field always move from from high potential to low potential. From positive to negative. Like a parallel plate, positive, negative. The field always directed down. If this is a positive 50 volt, and this is 0, yes, field always travel from high potential to low potential. So Vx as a high potential. But now, we go to the question, the answer. So which should be the answer? Okay. So of course, I believe A cannot be the answer, C cannot be the answer. either B or D. Vx must be higher and drop to lower one. But is it a straight line or a curve? It's a straight line. If it's a straight line, the gradient represents what? The V over D. The V over D is actually what? Is electric field, what? Electric field strength and the electric field strength. If it is a straight line, the field is constant or changing. If the V over D is a straight line, if the gradient is constant, that means E is constant, right? E is constant. You go back, the field, is it constant? If the field is constant, the field at X, and the field close to Y, is it same? It's not same, right? Why it's not same? How do you know field strength? You check the separation of the field line. If the field line is quite close, the field is strong. When the field line get further, the field get weaker, right? So EX is as a stronger field. EX is stronger field. Why? The field line is quite close. Okay, quite close. From the close, it gets further. But towards here, the field line looks parallel. Parallel means here after P. I say after P. After P looks like the E is constant. The E is constant. Okay, but from X to P, because the field line separation is from close get further, I can say the field is changing. And the field is changing. Field from stronger, it get weaker. The field get weaker. So which graph should be? The field is changing. Okay, the field is changing, sorry. Because the field is changing, what should be answer? So I go for B. It should be B. Let me clear this. How to clear it? Drawing canvas. Okay, so it should be B. Should be B because the gradient should change. Gradient change. At the beginning, gradient is greater. At later, gradients become constant. So field at the beginning stronger, field later become weaker. So answer should be B. Ken?
Yes.
Ken, good. Okay, any other question? Anyone?
For 20.
20, yeah. Okay, let's go for question 20. Yeah, just give a try. Question 20, spring. Okay, 20, yeah. Okay. A steel spring has a spring constant of 200 Newton. When 10 Newton of weight is hung from the spring, it has stretched for an extension of 60 centimeter. So, what was the original length of the spring? Original length of the spring. Okay, so spring. We don't know what is the original length. I put X naught. The force applied down is 10 Newton. And the K is 200. K is 200 Newton per meter. And it has stretched length of 60 centimeter. It has a stretched length. Is it extension or original length? It should be, stretched length of 60 centimeter. The stretched length, I think the total length of stretch is 60 centimeter. The total stretch length. So what was the original length? So use F equals to Kx. Find the extension first. So extension should be F over K. So F is how much? 10. Then K is how much? 200. So the extension alone should be how much? Cancel. So what do you get? 0.05. 0.05. 1 divided by 20. 0.05 lah. you get 0.05 meter. So therefore, in centimeter is like 5 cm. So the extension alone 5 cm. So 60 centimeter, the 60 centimeter is the total length. It's actually the original length plus the extension of 5 cm. So the original length should be, of course, the original length is how much? 55 cm or 0.55 meter. Okay, can I understand? Answer is D, yeah.
Yes.
D, yeah. So can I understand this is the working line? I think the 60 centimeter is the total length. Total length 60 centimeter. So you find the extension, the original length plus the extension is the total length 60 centimeters. So you can find the original length. Okay, any other question? Okay, good. Those who have tried, good. Work hard. The others who haven't tried, please do so. Okay. More effort means better results. Any other questions? So if you don't have, we can go to paper 2. Paper 2, normally paper 2 with the mark scheme should helpful. If you have still got problem, you can check. So any other questions, class? This paper? No questions.
Number 4.
Number 4, Okay, number 4. Okay. Okay, look at number 4. Measurement technique, your second topic. So the current I through a resistor measured by digital meter is 0.1 ampere. The uncertainty, the calculated I squared will be, oh, it's a digital meter. It's a digital meter. That means the ammeter is a digital meter, and on the screen, it displays 0.10 ampere. So this is the digital meter. It's a digital meter. Digital meter. What is the uncertainty of the reading you get from the digital meter? 0.10 plus minus how much? The smaller scale or half the smaller scale? Digital. Digital will be the smaller scale, right? When you go half of the smaller scale applies when the instrument is analog. If it's an analog, then you go half of the smaller scale. That's your plus minus uncertainty. Okay. So digital always smaller scale. So here for this reading, the uncertainty is, what is the smaller scale will be? 0.101, 2 decimal place. So it should be 0.01 smaller scale. This uncertainty you should imagine. Okay, small scale. So this is the reading with the uncertainty. So they're asking what is the uncertainty for I squared. So you put a formula. Y equals to I squared. Okay. You are looking for what? Y equals to I squared. You are looking for changes of Y over Y times 100%. Okay, because Y is I squared. Y equals I squared. So therefore, we are looking for changes of Y over Y times 100%. So what do we do? All right, the uncertainty formula for this. What is the uncertainty formula for Y and I squared? Changes of Y over Y will be what? 2. Changes of I over I, correct? Correct, right? So Y equals to Y we created. Y equals I squared. We want to find changes of Y over Y times 100% because Y is I squared. Okay, so of course times both sides 100%. Here 100%, here also 100%. Okay, we can work out the percentage uncertainty because we are looking for this. So 2 times changes of I is how much? This is changes of I, right? This is changes of I. This is your I. The change of I is 0.01 over I is 0.10 times 100%. This is your answer. Okay, so how much you get? 1 over 10. 100 over 10, 200 over 10, 20. Is it 20%? D. 20, yeah? So you got idea?
Yes.
Yes, so any digital instrument, the uncertainty is the smaller scale. You just put plus minus the smaller scale. Okay, let's say you have another digital scale. It portrays like this 0.105. So you should know the reading is 0.105 is plus minus 0.001. The smaller scale is the uncertainty. Okay. Any other question? No questions? So yeah, this is fine, no problem. Okay, so we go to paper 2. Okay, so I think no questions anymore, right? We go to paper 2. Okay, so we go to paper 2. Paper 2, the what do you call, the mark scheme should be quite helpful. But anyone got problem with the paper 2? Paper 2, July 15, I think I asked you to do. Anyone have questions about paper 2? After you check the mark scheme, after you check the mark scheme, anyone have any problem?
Sir,
Yeah.
when we find the percentage uncertainty, will there be any differences between the maximum and minimum percentage uncertainty? Like the value we find. For example, 2C.
2C, for which one? For this question, structure.
Yeah, this one.
Maximum percentage error. We always find the maximum percentage error. The percentage error we are finding is the maximum error possible. You see, you go and buy what do you call, okay, what I can say, okay, you buy a mass steel. You buy a block of aluminium, let's say a block of aluminium. Okay, over that aluminium, they stated is 2 kilogram. They stated is 2 kilogram. Okay, 2.00 kilogram they stated, and they said it's a plus minus 5%. So what do you understand by this? So this 2 kilogram has been this 2 kilogram, the cube has been made by a machine. Machine made that cube. Okay, compact the aluminum into a cube. But the machine has some tolerance. It can make some mistake because the machine, a systematic error can happen. They say it is plus minus 5%. Means what? This 2 kg can be fall under, the actual reading is 2 kg, but it can be 5% of the 2 kg more. 5%. To be easy, I put, let's say 10%. So 10% of 2 kg is how much? 0.2. So maximum can go is 2.2, minimum can go is 1.8. So when you purchase this, in your mind, you must set the reading. This way, you go and weigh into your weighing scale. Okay, the reading could be from 1.8 to 2.2. That's the percentage, the error. The percentage error they give here is always the maximum value. The maximum deviation can be. That's called maximum percentage error. Understand?
Okay. Yes.
Okay. Any other part you got problem? Paper 2? Okay. So if you don't have any questions, maybe I can select some questions from other paper.
Sir.
Yeah.
4B 3.
4B,
3. 4B number 3.
4B part 3, it's a grading 4B part 3. Oh, it's part 3. State 2 condition when the wave interfere if the resultant intensity is to be a minimum. State condition when the wave interfere. I think one of the condition it must interfere destructively. It must interfere destructively. Okay, should be destructive, then give the minimum. State 2 condition when the wave interfere of the resultant intensity is to be a minimum. And I think preferably same amplitude. What's the answer given?
They must meet at a point and same plane of polarization.
They must meet at a point.
Yeah.
State 2 condition when the wave interfere if the resultant intensity is to be minimum. Yeah, they talk about what is the condition to interfere. The answer given is what is the condition to interfere. Yeah, they must meet. They must meet at the same point. At the same point, the basic idea of interference. And to make a minimum, because they specify as a minimum, I believe you must say it meets up destructively. Okay, polarization, I think no need to include. Meet at a point, meet at the same point, and it must meet destructively, interfere destructively. Okay.
Okay.
Any other question? No questions. Okay, so if no questions, let's continue. Hopefully you tried all the questions. Remember, you have how many questions? You have 30 objective. You have 30 objective. Okay, 30 objective and 30 marks for structure. 30 marks of structure. So it's a 1.5 hours. Okay, so okay, so 30 objectives. So 30 objective. In a real 30 objective, 60 marks. So 75 divided by 60 marks, how much is it? So this is the time for you to spend for 1 mark of question. Every objective, I think you can spend how much? 1 hour, 1 quarter, 1.25 minutes for one objective. One objective question. You train like that. Okay. Every objective question you try, you must finish in 1.25 minutes. Then I think you just nice can finish the paper after 1.5 hours. Okay. This is very common. Every time people come to A levels, first semester exam, they know how to do, but problem is only the 75% of the paper has been finished. 25 empty. Reason asked, no time. So if you have time, please try to speed up doing the questions. Okay. So no questions. Okay, let me go through some other papers. I go through the papers which your seniors have problem. I go to paper 1, July 14. Let me select randomly one question. Okay. Okay, any question which this is the same one, right? Oh, this is the same one. Where's the paper? November, which paper I'm taking? Sorry. July 14, right? This is the paper, right? July 14 November. July 14 November. Oh, it's the same paper. The question looks the same. I think. Oh, this is the same paper. Okay, let me go to another one. Oh yeah, just now I asked you to do. Just now I asked you paper 1, July 14. Oh, the same paper. Okay, I go for July 13, paper 1. Okay, let me select some questions from here. Any questions? Okay, this question is good. Yeah, the question I'm asking you to do is the question which your seniors had problem last time, which really I can remember, and I deal with your seniors. Okay, question 6. What do you think the answer? You can WhatsApp me. Okay, so I can WhatsApp me your answer. What do you think? Okay, 2 of you said it's A. Is it all 3 correct? So I got 2 of you, or 3 of you said A. So all of you are quite same, but all of you said A. Okay, my advice is the 2 bodies are allowed to fall freely from the same location, one which released short time after another. First one released, then it goes down, the first one is already here, the first one is already here, the second body is released. Then this is the final location. So the one goes down, one is here and the 2 is here after a short time. Okay, so best is draw the VT graph. You draw VT graph, you can visualize the answer. Okay, VT graph. Can you draw the VT graph for the both body? First body, how's the VT graph for the first body, right? Looks like, let's say drop for the time 0. T1 drop and time is 0. T2 drop and the time is T1. I put T1. So first body, how the graph looks like? It's going to be a straight line, right? It's going to be a straight line because gradient is your gravity. Okay, this is for the first body. Second body, it dropped when the time is T1. The time is T1. Okay, so the T1, how the second body graph going to look like? Also going to be like this, right? It's going to be like this for second body because gradient have to be the same because same gravity. Okay, now let's see from this graph. First, 2 bodies have the same acceleration. That's correct. All of them have the 9.81. So 1 definitely correct. 2, their speed always differ by the same amount. Is it the same amount every moment? It is the same amount. You check from the graph. Okay, you check from the graph. Every moment, this is the differences. And the time T2, this is the differences. The time T3, this is the differences. Yes, the differences looks the same. The differences in the velocity, their velocity, the both bodies velocity. The differences looks the same. Yes, correct. 2 is correct. Okay, now the third one. Their distance of separation, is it always the same? Okay, the third one, is it correct? That one, is it correct? Okay, I go for the third one. Okay, third one, you see, and when the time is T1, when the time is T1, which area is the separation? This is your separation now. This area is the separation between the body 1 and body 2. Right? This is the separation. This is the separation. Or in other words, in the diagram here, when the 1 is already reached here, 2 is already reached here, this is the separation. The separation is actually this area. This area. You now tell me, T2, after it dropped, the 1 already traveled the area in the graph of 1. Okay, this is the area under graph of 1. This is the total distance traveled by the 1. Okay, 2 travel which distance? 2 only travel this distance. What is the new separation? The new separation is this area. This is the area of separation. This is your area of separation. So when you go for T3, the area of separation is increasing. They separated greater distance because in every moment, the speed of 1 will be greater than the speed of 2 at any moment. Okay, let's say this is 20 meter per second. This is 10 meter per second when the time T1. This one is traveling 20 meter in 1 second. You are traveling only 10 meter 1 second. After T2, your speed of 1 always going to be greater than the speed of the 2. So therefore, the 1 will always cover the greater distance, you know. So their distance of separation is always same, is wrong. The separation distance always increases. So therefore, the answer going to be B. B is the answer. Okay, get the idea. Okay, anyone have a problem? So you draw VT graph, I think get the idea. Okay, class, good. So this is which paper? This is a paper I'm just discussing just now. Is paper 1, July 13. Okay. For tomorrow, we give a try. Paper 1, July 13, and paper 2, March 14. For tomorrow, give a try. Okay. So I see you tomorrow. Any questions? No questions, eh? Okay, good. Your class is quite good. You are good at asking lots of questions. Okay, those who are not asking, I think better you try to do and give a try. Okay, so I stop here today.